Alright everyone, welcome to the session where we're going to talk about, well, we're going to go from this web page into something that's running in production, which hopefully should be running in production when this session ends in 45 minutes. And today I'm going to try a crazy experiment. I'm going to talk with a microphone without the sound for 45 minutes while live coding. That means that I'm going to try to shout as much as I can, but like please come further down if I speak too low. I'll try to figure it out, but you know, when you're coding, suddenly you lose focus on everything else than the coding. I'll try not to do that, but we'll see where we'll end up. So I have cheated just a little bit. We'll head into that in a minute. That's not a fun start. So let's start with the fun part, like downloading Quarkus and getting started. Then I'm going to tell you like what kind of cheating I've done, and then we're going to go further into the path from nothing to production. So what I've done so far. Oh, by the way, my name is Opheim. I live in Norway. I work in a Norwegian consultancy company called Kompetas. In my day-to-day work, I do Kotlin development with Cater. So I'm not like Red Hat is not paying me to do this talk. Just I like the technology. So for the record. That said, let's get started. So I googled Quarkus. That took me to Quarkus.io. From here, I do start coding, which takes me into this. Okay, yeah, thank you. Let's start coding. Okay, that takes me into this web page. Is it readable, by the way? Yeah, people nodding, good. Okay, so on this web page, like when you start out with a Quarkus project, I would recommend you go here. And from here you can say like, oh, I need this library or that library. Or, as in my case, I like Kotlin, as I said. So I want to do this demo in Kotlin. So here I search for Kotlin and like add extension Kotlin. That means that whenever I download the starter afterwards, it gives me the code with Kotlin as the demo code instead of Java. So I'm not going to do anything with like group ID and artifact ID and so on. You can of course do that. You can do Maven or Gradle. If you'd like to, that's fine. So I've selected Kotlin. That's all for now. You can add like panache or you can add lots of libraries here. Whatever floats your boat. For this simple demo application, we will be fine with just plain Quarkus. So I download the zip file. We can head into here. You can find the folder that's code with Quarkus. That's the default name unless you change it, which of course you would do. So I have prepared a project in IntelliJ. So now I can tell you what kind of cheating I've done. I have installed GraalVM. We'll be talking about GraalVM when we talk about native afterwards. I have created a GitHub repo, a project in Google Cloud. Here you can do Google Cloud, you can do Azure, Amazon, Oracle Cloud, whatever cloud fits your boat. I do Google Cloud because I'm familiar with it. I've enabled billing because cloud projects cost money. I think that this entire demo will cost me about €0.50. I've enabled some of the APIs in in Google Cloud, and I've done some role-specific stuff in Google Cloud, which we'll talk more about this one when we head into a cloud build part. And I've also authorized Google Cloud to access my GitHub repository. I think that's all the preparations I've done. Like the rest of it is actually going to be happening as we are here live. Okay, that's aside. Now we find these files are downloaded from starter. So I just simply pull them into my project in IntelliJ. I say refactor. That's what I should do. Refactor like this. Okay, it's gonna overwrite my README. That's file. I didn't do anything with my README. Add file to Git. That's fine as well. So now we can see that. Well, I have some files in here. Okay. So you can see that. Okay. Yeah, this is fine. Okay. My keyboard isn't working perfectly with the, but that's demo effect, I guess. So let's just do a simple reload so that IntelliJ understands that this is actually a Maven project. Makes everything easier now. So now we can see that, okay, this starter has created a resource for me. That's a plain REST endpoint. And it has also give me a POM file with some dependencies. Something okay, something wrong with all the colors here. Okay, what we also can see here, especially if my keyboard was working, there. Okay, is that on the bottom of the file you have the profile native, which is we're going to be utilizing when we are using Quarkus Native afterwards. But let's start out rather easy with what we have available. So we head over to a browser, we see localhost 8080, nothing running. So let's do something about that. I head into my terminal, I do maven daemon compile, and then we say Quarkus dev. That's like the dev mode of Quarkus, so that whenever you reload the page, it reloads the code automatically, which we'll see in a moment. So now Quarkus started in 1.3 seconds. I reload, and voila, you made a Quarkus application, which runs on my computer, but that's fine. So the default endpoint, the one we saw in the greeting resource file, is by default available at /hello. It says hello from REST easy reactive. And you can see that we are using something from Jakarta REST service here, like the path annotation, the get, and the producers. So let's add a little bit more fun. Let's add a class. We call it JCON service, because why not? That can be application scoped. For those of you who went to Adam Bien's talk earlier, you can say, oh, that's why he's using application scope, not request scope, because, well, in the end we're going to do this serverless. Like everything we're talking about today, you can do serverless or non-serverless. I'm going to do serverless because that fits with the use case you might often have, like as a backend for a front end, or something that's typically available during the work days but not interested in the evenings, or other way around. Which is where I find Quarkus Native to be really suitable, to be running serverless. We'll come back to all of this in a few minutes. So our service, let's say, it can have a method says hi JCON, which just returns JCON. Okay. And now we are going to inject it. We could say service. We could even say private val JCON service like this. And instead of saying hello from REST easy reactive, we could say hello from REST easy reactive at, and then we could say hi JCON like this, and I save it. I head over to my browser, I reload this page, and now we can see that the changes are reloaded into it. So that's one of the really cool parts of the developer experience of doing development with Quarkus. It gives you this out of the box. And you can of course also do lots of things. You can do you can do regular coding here, so that's fine. That's not like topic of the day, but just to show you why I like Quarkus. Okay, so now we can also do things like if we head over to localhost 8080/q, you can get like, okay, what are currently you get resource not found, but you can see like here's a list. Maybe you could add whatever you write here, you get this 404 page, which also practically enough lists out okay what endpoints are available. You probably should not expose this in production, but like for development it's fine. And you can see that, well, there are no health services here, right? If you want my liveness probes, readiness probes, even startup probes for Kubernetes, Quarkus supports that, but I'm not. That's an extra dependency, which I have not included. But we can head back to the starter, and we can look for health. You can see that here there are several health things. So small y health, that's the microprofile health implementation. That's the one I want. So, okay, where did I do this? Okay, so if I head over to right here and like expand this one, you can see. Okay. Now you can hopefully see. You can see like copy commands, copy maven commands, and so on. So what I need is just the dependency because it's part of the version and so on are controlled by the BOM file, the bill of materials in Maven. So the versioning and so on is set there. So all I need is to add just the dependency. So I copy it. You can do this manually. It's perfectly fine. And I head over into dependencies. Okay. Dependency management, dependencies. Here we are. Which is like, okay, we're using Quarkus Kotlin. Okay, let's add small y health. Now I save it. You can see that it automatically rebuilds. And you can see that small y health is added here as a dependency of the project. And if I head back here now, you can see that it's added all the health endpoints. So you can even like configure POM file or even Gradle build files live and reload and have hot reloading of it, which is pretty cool. But that's not what. Okay, so with that in mind, let's head over to like, okay, but what about the Dockerfile things, like Docker container? Okay, now it's running perfectly fine on my computer. Cool. Now what? So by default, when you download the starter for Quarkus, you get some Docker files, and you can see that you have one which is named .jvm, one legacy jar, and two that are native and native micro. And these concepts are pretty much similar in Quarkus as they are in Spring, Spring Boot, and also I think this is coming to lots of the application servers. So you can run Quarkus in JVM mode, like inside the JVM, as you typically do. That's what I typically do on my local computer or for an application that's intended to be running long time or all these things. But you can also run Quarkus Native in native mode, so you get a binary which you can run independently without the JVM around it. And the major benefits of native, just to get that said, is that, well, when you do run native, your application starts really fast. So that means like whenever you need to scale up or scale down, especially scale up, like also scale down really fast, native is probably a good idea. You could also do things like crack, container restore, checkpoint, or like other techniques, but native mode using GraalVM, which is it's GraalVM under the hood. It's a great way of doing it. So it fits perfectly well with Serverless. So with that said, what we want to do, right? I'm a developer. I'm not an engineer, and I'm not really into ops. I'm not into like configuring build files and so on. So like I want to do my production code or my business code, business logic, and do git push, and then I want everything to happen automatically, right? So, and here's like what I don't like about this Dockerfile hits exactly on that point, because it says, you can probably see on the top where it says that before building the container image, run Maven package. It's like, what? I want to do that. I want that to be done by this Dockerfile. So I'm not really satisfied with the default Dockerfile provided for native mode. Like it's nice, like if you do programming locally on your computer, this is fine, right? You could do Maven package on your computer, and then you could do Docker build on your computer, which is great. But like on a build pipeline, I want everything to be controlled through my Dockerfile. So, which is why what you see here is not. I don't consider it to be good enough. So, the way I want it to be done is like I want the Dockerfile to start with packaging the code. I wanted to build a native container, and then I wanted to run the container. So let's actually do that. And no, I'm cheating a little bit, because like this is code I'm going to screw up if I'm going to write on the fly. So, but let's just write a Dockerfile. We create a new file. It's a Dockerfile. Get it to Git. And now I'm cheating a little bit. So the first thing we do is like we build the code. And here you can see that okay, isn't that lots of steps? And yes, it is. So what we're doing here is we're starting out from Maven base image, like regular Maven with Eclipse Tamarin as the Java runtime. We copy our POM file into the image, and we run Maven verify with that POM file. Why do we do that? Because we want to leverage the layering system of Docker. So typically in a backend application, my dependencies don't change that often. My own code changes much more often. So when we are doing Maven verify with just the POM file, we are downloading the dependencies. So next time, like I'm changing only my code, all of this is cached already. It's available in the cache. So new work is starting from here when you're copying the source, and then you are running Maven package, and then you can see like what the heck is this parameter. So it says, okay, Maven, do the packaging, but when you are packaging the code, package it in order to, as in the next step, do native compilation. So let's start out like doing just copying this code into our Dockerfile. Okay, so I said in the next step do native build. So let's do that. So here you can see that we're starting out with Quarkus mandrel. And mandrel, the base image here, that's a subset of GraalVM, just intended for only the native image part of GraalVM. GraalVM has a lot of other things, which is not really needed exactly here. So what Red Hat, which has created mandrel, has done, they took like, okay, this is the native image part. We take that one, we suit it for, we tailor it for Quarkus, and then we go. So we start from that one. We copy the sources we prepared in the previous stage, and then we do native image build. The native image command, that's part of GraalVM. And you can also see that the last thing we add here is a parameter saying how much memory do we want to give the native image generation. And as those of you who were in the previous talk heard, that like GraalVM uses a lot of memory. So like 4 gigabyte, enough for like a tiny application like this. Probably not enough for your business application, but like you very easily notice that, because when you get an out of memory, then you need more memory. That's how easy it is. So you'll notice. Okay, so after this step, once we've done these two stages, we have prepared the image. So what we need now is to actually run the image. So here we start out with a Quarkus micro image, which is like the recommended base image from Red Hat for Quarkus. We copy the runner, like the application for the previous step. We do some chmod exposing thing, and then we run it. Then we run the application. So this is the Dockerfile that like gives me the build flow I want, which we now have prepared. So, okay, yeah, and now we can, before heading further, we can actually run Quarkus locally in native mode as well, because why not? So the way we do that is to say maven d package, and we say profile native. So now Maven is building then with a native profile. Oops. Test failures. Oh, right. Because that's a good one. Because we updated the endpoint, right? So the starter comes with an endpoint with a test that says, okay, whenever I'm invoking the hello endpoint, I'm expecting hello from REST-DC reactive, but now we're also getting it at JCON, right? So I'm going to do the quick and dirty version. Like what you should do is fix the test, of course. Maybe even have your own tests with. Okay, what we're actually going to do is not even this. Let's just really hack, and then we try again. Even more test failures. Okay. Okay. We might actually be doing a clean package. Alright, so there are more. Okay, so the testing is going to be another talk. I'm not focusing on that now, but yeah, fix the tests. So now we are building. You can see GraalVM native image here. You could see it for a few seconds. I did this like some minutes ago, so it shouldn't take too long now, but this could take probably a couple of minutes. But of course, depends on your computer and lots of stuff. So you can see that GraalVM is doing quite a lot of stuff under the hood. Yeah, we have time, so it's fine. Let's give it a minute and see. Okay, so now you can see, okay, nothing is happening here. Like my code is not, my application service stopped, right? Okay, so build success at 50.1 seconds. This is a MacBook Pro from last year. So like, it's lots of work happening. what we can do now is invoke the runner with the application. Okay. Do we want to approve? Okay, let's do that for now. And what we can see here is that the application server started in 0.027 seconds. Like crazy fast startup times with native mode. Now we're up and running locally on my computer, which was what I wanted to show you now. So the next stage we can do is that we can head over to Google Cloud Build. So I've been doing some preparations just in case the internet didn't want us or anything. Let's try to do this the proper way right now. Okay. So let's actually delete. Okay, let's ignore that one. Okay, say JCON live, because we are live, right? Currently I'm using region global. You should probably use I don't know, Europe West or something. You could say that, okay, this is Google Cloud Build, but you could do this, maybe it's mainly the same things in like GitHub Actions or Azure Functions or whatever build tool you have a choice. Cool. So I have to say, whenever I push to a branch in my GitHub repository, whenever I push the branch, well, say main, then I want something to happen. Okay, and here we see you can have a global.yaml file or a Dockerfile will be detected in the repository. So you could do auto detect. I don't trust that one. I want to specify it myself. Mainly because I'm paranoid, but like some control. And you can see global YAML file. How many of you are familiar with Google Cloud Build, by the way? One, two per. Okay, a couple of persons. Okay, so global.yaml, that's corresponds to, like, in GitHub Actions you have the workflow YAML files. In Jenkins you have Jenkins files, like vendor build system specific config files telling you how to do the build. And why do I want a specific global YAML file here, and not using just the Docker file that I just showed you? So let me answer that by showing you what the file would look like, and then we'll see the answer pretty soon. So we do a global YAML. Here also I cheat a little bit. So you can see that here it says run deploy. So it's actually going to, whenever this YAML file is invoked in Google Cloud Build, it's going to deploy my application to Google Cloud Run. That's why I want the specific. That's the main reason why I want a specific YAML file here. And also we specify that, well, I want it to be in Northern Europe. And I want to allow for an authenticated requests so that it's available for the entire internet. So, and like, don't use more than 20 minutes. Like, it shouldn't take that long, but like, I think default is 10 minutes, which might be too little actually, if you have a big application and you want to run it native. So this global YAML file should work. What's not going to work here is the fact that it's not going to utilize the Docker layer mechanisms, because Cloud by default doesn't do that. So that means that whenever we invoke a build, we start from scratch all the time. There are several ways you can come around that. One easy one is to use the tool called Kaneko. I think it's from Google, at least they are involved, and it's well supported in GCP. And that says, well, let's use the cache, pretty much. And then you add that as a step in the build file. So let's do this properly, like this. And now it's going to actually cache the layers in the Docker file. And what more do we need? This will actually work, but as we have 20 more minutes, it's going to take too long. So we need to add some more machine power. So on Google Cloud, you can say use a heavier, like the default machine you get when you start a build job. It's not that powerful. It's usable, but it's not crazy powerful. But you can say, well, give me a machine with lots of computing power, which will of course be faster. So let's do that. And that is pretty much it, what we need. So now we are going to add. Okay, so let's add to Git. Now we have all the source code, the POM file, the Dockerfile that we just created, and the global YAML file. Let's create it. Let's commit it, and said, "Hi JCON," which is a great commit message, right? Commit. Okay, and then we do a git. Then we do a git push. So now all my code here is committed to the main branch on GitHub. So what we can do here in our trigger, which we are creating before we took the detour back to set up things, right? We can say that, well, whenever a push is made to main, then we want to invoke the build as specified in the global YAML file. And here you can do things like secrets or environment variables or like different accounts and so on. We're not going to do that now, but you can perfectly fine do that. So you can see our new trigger, the upper one, and my preparations is the lower one, which you hopefully won't need at all. So let's actually try to run this. Okay, so now the build is starting. So while the build is running, let's head over to Google Cloud Run. That's Google's serverless solution. So like say, yeah, it's similar to Amazon Lambda, or it is something in Azure as well. But like, yeah, it's a serverless solution from Google. So the one I cheated with and prepared with, it's called JCON. Our new one is called JCON Live. So it'll hopefully show up here in a minute. And okay, so yeah, waiting to run build. So this build is actually going to create the run, or like the application in the Cloud Run serverless thing. And you remember that earlier on I spoke about, okay, what preparations did I do? And what I did do is like give these roles, because if I don't, Google Cloud Build won't be allowed to create the solution in Google Cloud Run, and won't be allowed to say that it should run. It should be available for everyone, not just for specific users. So now our build has started, and what we saw a minute ago was that the build was queued, right? It was waiting. That's the downside of using a more powerful machine, is that Google don't have that many of the powerful machines, so you might have to wait a bit for them to become available. But the good thing is that, well, the build is faster. So it like, in general, it pays off. So now we can see that our build is going. Lots of things happening, downloading and so on. Oops. Yeah, now we're doing the actually creating the native image part, which is the heavy lifting of the build. It should probably take around 2 minutes total for this small application. So let's let that build continue, and let's see what more we want to talk about today. Yeah, we talked about this, we talked about this, well, actually we talked about most things. That means that we probably have time for some questions in a couple of minutes, if you have anything. Well, we can see that Cloud Build is working on, and it's inlining methods. You can see like 5 out of 7 or so on. And what we can see here is that this is quite a heavy build, which means that the build time is going to go up if you go native, but like the startup time is going to go down. So whether that fits you or not, I don't know. Depends, of course, on lots of things. Okay, now we can see it actually. Okay, come on. Push. Okay. Okay, so done. Yeah, 2 minutes and 41 seconds. for like the simplest application. That's like the baseline for the simplest application you have. And now we can see that, well, we have this JCON live, Europe North, allow unauthenticated, and deployed just now by Cloud Build. And you can see here we have the URL. So let's copy it, and let's add it into add /hello, as we remember where that was our endpoint, and we run it. Yeah. And now we're available on the internet. We're hello reactive at JCON. That means, right, that, well, we started out with nothing, you saw that. Now we are in production in 30 minutes, which is pretty awesome. So let's have a look at a short look at the logs. So what happens here? So you can see, probably can see, yeah. It's a bit small on my screen. Let's try the log explorer. It doesn't really help. Okay, so you can see Quarkus Native started in 0.2 seconds. That was like the deploying startup thing. And when we invoked it, it started in 0.157 seconds. And the exact numbers aren't important. The important thing is that, like, this is fast enough that your users won't be impatient. That, like, most users will actually wait for your application to start up and be doing what they came from. They won't be like disturbed or like I'm not going to wait for this anymore kind of thing. So I told you when we started out that I've been working with the technology on a side project. I've been doing that for a bit over 2 years. We're having like Quarkus Native backend running in production. There's a typical application where you have a user every now and then, which does the thing, and then suddenly, like some periods of the year, there are lots of users. Like in a regular month, we have like 3 users or something in total. So like it perfectly makes sense to scale down, but we need to scale up fast enough that people don't get tired. Which is what like this technology stack is very suitable for. So I think we're actually done our thing. We cheated a little bit with the tests. Like, don't delete your tests, fix them. But other than that, we haven't cheated that much. Like, we've done things pretty good. Like, we have a Dockerfile that. Well, let's do that. That's kind of fun. Let's head back to Cloud Build. Let's trigger a new build to see like what happens. Because this is pretty cool. Yeah, I'm a geek, I know, but I think this one's pretty cool. So let's see what happens. You can see the history of the builds here. So yeah, it's queued up, as I told you. Okay, can we? Yeah, so you can see like, yeah, Google gives you a lot of information, which is I hardly ever used, but like it's here. You can see how long the build was queued, for instance. So it's like half a minute. So like you might want to add that one to your like time to production consideration as well. Like how long does it actually need to start? How long time do we need to start the build process? Not really important for me. Might be for you, I don't know. But like what we can see now is like checking. You can see we started out with like downloading things. Downloading new. So you can see downloading the image for Kaneko, the caching mechanism. That's probably fine. So you can see returning cached image manifest. You can see here that we are using cached version of command package native sources. From cache layers, you can see that we are using the cache from Docker or Podman or whatever. It fits with different containers. So you can use it in the cached mechanism all the way. So you can see that, well, it's hardly ever changed. Like nothing changed in the code, right? So everything is as it was in the cache. So just reusing the cache. So now we're done in yeah, 34 seconds. That was like the build process thing with that figuring out that oh everything is in the cache, and then the deploy part took to 20 seconds. And like if we head back here, you can see that yeah, it says okay. So let's for fun let's head over to the greeting resource and say hello JCON, and then we can add system current time millis so that it differs. Now we push it to say add more response for it, so that every time we invoke the endpoint we get something new. And I push it, and now we should see back in cloud build that it actually starts a new build. You can see it here. It's the waiting image here, the icon for waiting. So the build started when I did the git push. It starts immediately, or like it queues up immediately. More correct to say. So now it's going to build a new version of the application with the change I just made and pushed it into production. And it's going to take probably a couple of minutes as well. Yeah. So yeah, let's just wait for this. But like, are there any questions on the front here? Non-blocking reactive. I haven't really looked into that. So I'm not sure. Should be possible to do. Okay. Yeah. Yeah. Ooh. Um. I guess it depends who you ask, but like, Quarkus is like I would say like the entire ecosystem kind of thing, in the sense that Spring has lots of its own Spring packages thing, but while Quarkus uses like Vertex and Hibernate, like all of the libraries typically in the other kind of ecosystem. So I would say Quarkus is more part of the Jakarta EE family application service, so that if you try Quarkus and don't like it, you can rather easily switch to OpenLiberty or Payara or one of the other application servers, whereas Spring is more its own ecosystem. So that's the brief summary. But what we can say about Quarkus in specific though is that Quarkus is created to be run inside containers. So that means, and that's also what Quarkus in general is really fast compared to like almost everything else. And that's because while a typical Java application server listens for like drop-in beans and things happening dynamically as the application server is running, Quarkus don't support that. It's intended to be run inside a container, which means that whatever you have at build time is what we create for you, or like what you have at build time is what you get in the container. So when Quarkus starts up, it doesn't need to look for things happening runtime, which again is a trade-off though, because you're trading build time for runtime, right? So yeah, I'd say that's the main difference. See. And yeah, and here we are. Our build is done. Now you can see that it took 2 minutes and 16 seconds. So we should see something here like that it's using the cached. Yeah, you can see here using cached layer version of CMD. Okay, not sure if it's visible. Is my pointer visible on the screen? Yeah, it is. Okay. So that's why we did the separate step in the Dockerfile, right? To download the dependencies first. Because now I changed my code. I did not change the dependencies. So we can reuse that layer. So that saves us for 30 seconds in this context. But like in a real application, you typically have some more dependencies. So everything will take longer. So that also means that you save more time. That said, let's head back to the application and see if our change is live. It is. Okay, so now that's 58, 63. Okay, so it changes every time we invoke it. That's pretty much it. Yeah, I think I'm. Do you have any more questions? We have 5 minutes left. Yeah. Yeah. Oh. Because I haven't used Jib that much. Pretty. Yeah. I've yeah, it should be perfectly possible. So. Yeah. Yep. It's all in one, but it's like it's multi-stage. Uh, yeah, so this is almost there. So we are using 3 separate base images, and so it's a multi-stage build, but this is the entire Dockerfile. Yep. Is there anything you were looking for in particular? Yeah. Yeah, of course. Yeah, it is. Yeah, I can add. I can share the link on Twitter afterwards, or I can even show you the link right now. It's on my GitHub page, repositories. Yeah. So, if you want to look into what we just did, or my preparations, you could find another branch here, the one called Take One, and what the changes we just did is on the main branch. So have a look at it. I'm here for the rest of the day, so come see me afterwards if you have any questions. Thank you all for your time.